Hey everybody, it's Cal here from Wise Guys Tutoring. Today what we're going to be covering is angles in parallel lines and a transversal, which is a really interesting topic. So let's get started. So first thing we want to see is what we call vertical angles. And some people call these opposite angles. And I'll show you why. It's because they're opposite to each other. So whenever you have this kind of cross of two lines that intersect like this, you'll always get a pair. Let's call these angle 1 and angle 2. These are called vertical angles or opposite angles. And whenever this happens, these two angles are congruent. Now, I'm going to be using that word a lot, congruent, and all it means is equal. But you see, for shapes, we can't say two shapes or two geometric elements like lines or angles. We can't say, this triangle is equal to that triangle. So we use the word congruent, but that's what it means. So in this case, we'll say angle 1 is congruent to angle 2. Okay, so vertical angles are always congruent. The next thing we're going to see is what we call a linear pair, which is also really, prevalent. You'll see it a lot. So this is a linear pair. You got one angle here, and you got another one just on the other side. Now these two are called a linear pair, and you can probably tell that angles in a linear pair form 180 degrees together. Let's call this angle 1 and angle 2. So we can say that angle 1, the measure of angle 1 rather, and the measure of angle 2 equals 180 degrees. So for example, if this one was like 150 degrees, then we can be certain that this one in the other, the other angle of the linear pair is 30 degrees because 150 plus 30 make 180. So now let's get into the parallel line situation. So parallel lines, as you know, are lines that will never ever intersect, right? They run infinitely without intersecting. And what we're going to put here is what we call a transversal. And a transversal is just a line that, intersects two other lines at two different points like this. I'm going to put these two arrows here to indicate that these two dark blue lines, they're actually parallel, right? So what do we have here? So we have two angles. We'll start with these two, which are on the inside of the two parallel lines, and they're on opposite sides of this light blue line. So what we call these, we call them alternate interior angles. Okay, now alternate means they are on different sides of the light blue line. One is on the left and one is on the right. And interior refers to the fact that they are in between these two parallel lines, right? Interior, in between these two lines. Now let me name them again, angle 1 and angle 2. And now I can surely say that if these two lines are parallel, then angle 1 is congruent to angle 2. So remember, all that means is that the measure of angle 1 is equal to the measure of angle 2, right? So if angle 1 is like 40 degrees and angle 2 is also 40 degrees. Here's another pair of alternate interior angles, right? You have these pink angles here, let's call them 3 and 4. So 3 and 4 are also alternate interior angles. Remember, alternate means one is on the right of this light blue line and one is on the left. And interior means they're in between the parallel lines. So actually 3 and 4 will also be congruent angles. Okay, so their measures will be the same. All right. So another super similar type of angles is called alternate exterior. So let's go that. So these are my parallel lines, and hopefully you can probably have figured by now that exterior means they'll be on the outside. So for example, this angle with this angle, we call these alternate exterior angles. Exterior. Why do we say that? Because alternate refers to they are on different sides of that light blue line, and exterior means they're on the outside of these two parallel lines. So angle 1 and angle 2 will also be congruent in the case of parallel lines. So there you go. We also have obviously this green one with this green one. Let's call them 3 and 4 again. So 3 and 4 are also alternate exterior, and therefore they will also be congruent angles. That means their measure is going to be the same. Okay, so let's keep going. Now we have a couple of more types. So let me do another couple of parallel lines here, and here's my transversal, and let me put a couple of arrows just to make sure I denote correctly that these two lines are parallel. So we have something now called co-interior angles. So let me show you what those look like. Co-interior. Now interior, you should remember that here, let me write it over here. So these are called co-interior angles. Now we can remember that interior means in between the parallel lines. And the difference between these ones is that instead of being on alternate sides of this transversal, they're actually both going to be on the same side, right? So let's call these angle 1 and angle 2. So when you have these co-interior angles, this is what we're going to say. We're going to say that measure of angle 1 plus measure of angle 2 equals 180. So these are 180. They're not congruent. I knew you thought I was going to say congruent, didn't you? But listen, co-interior are supplementary. That means they add up to 180. They are not congruent. And even if you look at it, look, angle 1 is an acute angle, whereas angle 2 looks, bigger than 90. It's an obtuse angle. So they will not be congruent, people. They will not be congruent. Another pair of co-interior angles would be here, this one and this one. Again, I can name them 3 and 4 if you like. But that means that these two are also equal to 180 when I add them up. They are not congruent, okay? Maybe I should write that down. So co-interior angles not congruent in parallel lines. They are not congruent in parallel lines. Unless, of course, unless they were each 90. Then that would be fine. They can be 90 and 90. That's a good combo too, but that would mean that this line is perpendicular, which is a special case, I guess. Okay, so co-interior, add up to 180. So the last type we're going to see together is actually the one that students usually have the most trouble with. Kind of tight on space here. I hope it's still clear to you guys. So here's the two parallel lines and here's my transversal. So we call these angles corresponding angles. Okay, let me show you what those are. So you see, you have two intersections, right? You have one up top and you have one on the bottom. So this is what we're going to do. We're going to take the, top left quarter, if you will, and we're going to take the top left quarter here. These two angles are corresponding, as are the top right with the top right, as is the bottom left with the bottom left, as is the bottom right with the bottom right. So each, I've color coordinated it here for you guys. Color coordinated it. Did you hear me? Anyway, the green is congruent to the green one. The red one's congruent to the red one. Blue one's congruent to the blue one, and orange one's congruent to. All corresponding angles are congruent to each other when you have parallel lines. All right. So they are congruent, but you got to be careful which one is with which. The way I like to think about it is I kind of picture that, there are two different intersections. You got this intersection and you have this intersection. It's like people sitting at a table, and then if you change table, everybody else, same seats. Okay. So the red guy wants to be on the top right and the blue guy wants to be on the top left and whatever. Okay. Whenever you see these, so let's imagine the blue one is like 105 degrees or something, then this one will also be 105 degrees, which would make this one here 75 degrees, right? Because they are a linear pair, and that would mean this one is 75. So whenever you have parallel lines, you're going to get corresponding angles that are congruent. Okay. The last thing I would like to tell you guys is we've been talking about parallel lines and what that means for their angles, but we can also use the converse to prove that two lines are parallel. So sometimes you'll get a question that looks like this. Let me just make a small sketch here. You'll get something like that, and they will give you, for example, this one is 110, and they'll tell you this angle here is also 110, and they'll ask you if these lines are parallel, and the answer is yes, because by way of corresponding angles being congruent, we can certainly state that these two lines are parallel. So either they give you two parallel lines, and that would, that would imply, or we can be sure that these angles are all congruent, like alternate interior, and the co-interior will add up to 180, or they can give us the angles and we can make that same inference about the lines being parallel. Okay, so the conditions that I'm talking about are congruent alternate interior angles, congruent alternate exterior angles, supplementary co-interior angles, that means they add up to 180, and congruent corresponding angles. So if you have any of these four conditions, any one of them, the others will all be true and your lines will be parallel. So as long as you can sort of prove or show that one pair of these angles is congruent, or in this case supplementary, then we know for sure that all four conditions are true and these lines are parallel. So that's it for these, parallel lines and transversal angle. I always liked this topic when I was a kid. I hope I've made it a little bit clearer, a little bit easier for you to understand. Make sure to subscribe to the channel, like the video, and please leave me some comments, feedback, suggestions, and we'll see you in the next video. Take care, guys.